why it is important, and then I'll go over the topics that we are going to learn as part of this course, right? And then if you guys have any questions, feel free to put it in the chat. I'll try to answer it as I speak. And also at the end, if you have any questions, probably last 5-10 minutes, we can open up for the Q&A, and you can unmute and ask questions. Okay. Yeah. So with this, we'll get started. So most of you who have joined today, I presume that you might be already doing performance testing or certain level of at least you would be part of the testing team, right? Might be a test lead or automation lead. Mostly, I expect you guys to be performance tester in this group at least, right? Which means as part of your regular work, you might be doing your non-functional requirement gathering. You might be doing scripting using Jmeter or LoadRunner, creating scenarios, executing, monitoring, certain level of monitoring and reporting. Right? Those are the things which typically a performance tester will do. Right? And depending upon your experience, your scope of work, you might be doing everything, or you might be just doing one or two aspect of these, whatever I mentioned. Okay. So this performance engineering course is tailored for transforming or upskilling the performance testers to a performance engineer, right? Which means if you are a performance tester with 1 year, 2 year, 3 year, 5 year, 8 year, 10 year, whatever experience you have, right? To transform you or to upskill you uh, more to the relevant that is expected in today's job market or in the projects, to that level, we want you to get transformed, right? And if you are a test lead, right, if you're a test manager, you might not be a performance tester, you might be an overall test manager or a test lead, right? And you might be having a role of managing the both manual testing, automation testing, and the performance testing as well, right? So from your perspective as well, it is good to learn all these engineering concepts, though you might not be working technically, but to manage the performance testers and engineers, it is very important for you to understand, learn all these topics as well, right? So end of the course, what we want you to, so if you're going to go and introduce yourself in an interview, right, or to a project. Now, what you will normally tell is you are a performance tester, you know LoadRunner or Jmeter. You will be telling that I will be able to do a scripting, I'll be able to do an execution, I create report. That is what you will tell about your experience or your skill set, right? From there, what we want is after you complete the course, after you do hands-on at least once, whatever you're learning, if you at least do hands-on once, you should be able to go and confidently say that on top of the performance testing, you know performance engineering, you know server-side profiling in terms of CPU profiling, in terms of memory leak analysis, memory profiling, client-side profiling, right? Both client-side and server-side, from a response time perspective, from a CPU perspective, from a memory perspective, you should be able to do the profiling. And you should be good enough to analyze the heap, take the heap dump, take the thread dump wherever necessary. During a load test, something goes wrong, you should be able to go and take a heap dump and thread dump, and you should be good at analyzing those dumps as well. So when you go and project yourself, you should be able to say that I know these things. I know server-side profiling, I know heap dump, I know thread dump, I know what to look into the AWR report. I have used JProfiler, I have used JVisual VM, I have used JConsole. I know how to benchmark and fine-tune my JVM. I have used the APM tool like AppDynamics for the deep dive diagnostics. I know how to monitor my server, application, and database using both open source and your commercial tools. Right? So you should be able to go and project yourself with all these engineering related skill set. That is what we wanted you to get transformed. right? Additionally, since in most of the enterprise architecture, you would be seeing Python in the enterprise. So your enterprise architecture will involve multiple components, obviously, right? You will have Java, you will have some middleware like MQ or a Kafka. You might have a databases, you might have mainframe, you might also have the Python layer, because in most of the places, most of the projects, there is going to be a some kind of a machine learning data science component using Python, right? So so we also wanted to probably provide you uh, good level of or some level of insight on how you will be able to go and monitor those Python specific components. If at all if there's a performance problem, how you can go and profile those Python applications, and what are the typical problem, or how the actual Python layer is going to be structured when it comes to machine learning, right? So those as well, we would wanted to give you that additional learning as part of the performance engineering, right? So I'll go over one by one, right? But basically, from the course perspective, this is what at the end of the course, end of you doing an at least one time the hands-on all these things, you would be able to do hands-on on all these things, because whatever tool I use, whatever software I use, you should be able to use it on your laptop. Either it is going to be an open source, or if it is a commercial, there is going to be a trial license going to be available. Okay. Okay. Very broader view of various activities across your life cycle, right? So generally, um, see, when we say performance engineering, right, it is going to be a combination of multiple things. One is, of course, your testing, which is already you might be doing it. Performance testing is one part of the engineering which you are already doing it, right? Based on the non-functional requirement, you will be doing a scripting, and you will be executing it as per the workload, and you will be analyzing it. That's a testing, right? And apart from this, you have the programming, system analysis, and networking. For a performance engineer, all these four aspects are important. The programming, the reason they have kept the programming here is, you're not going to be a programmer. You're not going to write programs. You're not going to go into the code level and provide the changes. No, we are not going to do that, right? We are not going to be expert in Java. We are not going to be expert in .NET. We are not going to be expert in Python. No, right? So the programming, what it means is, you should be aware of certain terminologies, the way the application is going to work, so that you can confidently go and talk to the developer, right? In terms of Java, you should at least know what is class, what is method, how a multiple class can be invoked, what is object, how a Java is going to work, what is JVM, what is jar, what is var. So the nuances of the programming, the terminologies of the programming, you should know, because when you do performance engineering, you're going to find problems. You're going to find the root cause of the problems, and you're going to go and report to the developer saying that there is a problem in this class file, in this method, in this object. It should not be a black box for you. Otherwise, your developer will easily will be will not accept your recommendation, or they will not even respect your recommendation, right? Normally, even with the performance testing results, when we go and provide that to the developer, they will say that your script is wrong, your data is wrong, because I don't see any problem with the performance. That's what their typical response would be, right? Now, you're going to pinpoint a problem in their code, in their class, in their method. So you cannot just go with what JProfiler says, or what AppDynamics says, or what a Python profiler says. You cannot just go and talk to them what a tool says, right? They are going to say that they will somehow will easily convince you, saying that there's no problem. Okay, so that perspective, you should know certain things from a programming perspective. That is what it is mentioned here. And when it comes to networking and administration, you should be comfortable enough to go and install tools, install softwares, configure it. Right? In today's world, um, you cannot expect another team to come and install you the JProfiler or your Tomcat, or deploying the code. There will be instruction that will be available. See, every project, every place, everything is going to be new. There's not going to be a single way of doing certain things. When it comes to deployment, installation, configuration, it's going to be varied from a project to project. They will be having instructions, there will be a guide. You should be open enough to go and do this on your own, right? So that is where networking and administration comes into picture. It is not like you are going to be a network engineer or administrator. No, you should have an open mind where you should be able to go to a mission. You should be able to install the softwares, install the tools, and do things by yourself. Whether you will be able to do it everything by yourself, day one, day two, no. Nobody, you, me, everybody will not be able to do everything on our own. But we should have that open mind. There is going to be a documentation available. There is going to be people available. We should be confident enough to go and ask, gather information, and do it yourself. That's mindset we have to have it. For a performance engineer, you should have a mindset of there are going to be problems. Things are not going to work as we expect. There is going to be a problem with when you install tools. You're going to have a problem. When you're going to analyze a problem, you might not get an answer very easily. When you look for a response time problem, when you look for memory problem, you might not get an answer immediately. You might not even get it at all, right? So analysis is all about finding out answers, but not every time you might find answer, right? So you should have that mindset of um, uh, you should not think that I might fail, I might not be able to do it. No, right? Everybody, including me, 5 out of 10 times I might not be able to find out anything at all. That's still fine. But remaining 5 times I will be able to find out something. As you go on, as you gain experience, you will be able to do it. So all these things combined is what a performance engineering role or a performance engineer should know. All these things in this system analysis is a complete. I'll come to that system analysis. Testing, you might already been doing it. Programming, you should be comfortable with certain things, which I will cover it probably tomorrow or in the upcoming classes. Okay. So when it comes to system analysis, it is all about your performance engineering, right? Especially during a development phase and testing phase, you would be doing a code profiling, memory leak analysis, finding out the method hotspot, client-side profiling, benchmarking, heap dump, thread dump, JVM benchmarking. All these things you will be doing it during a development and testing phase. Okay, as a performance engineer, right? Um, there are certain activity left to development, right to the product, right to the testing. Okay, as you gain experience in as a performance engineer, you will be able to play more role in the requirement stage itself, in the design itself, working with the business team, working with the your development team, architects. You will be able to analyze the non-functional requirements and then review the design, and then at the design phase itself, you will be able to validate whether the design will be able to meet your SLAs or not, right? So your login functionality, your business team would have given a 5-second response time SLA. But when you look at the design, there might be 4 or 5 components for a login. It might go from an app server to a LDAP server or a single sign validation. It might go to database. So you will know that 3 seconds of SLA cannot be achieved, right? So those kind of a validation, you as a performance architect, as you gain experience, you would be able to do it during the requirement and design phase. But as a beginner, as a 1 year, 2 year, 3 year, 4 year experience performance engineer, you will be more relevant during a development stage and the testing. And one more very important difference from a testing and engineering is um, if you're a performance tester, you would get onboarded maybe during a testing phase, and you will create scripts, execute, and provide the report. If you're a performance engineer, you will get onboarded right from the development stage as the application is getting developed one by one, function by function, component by component, service by service. You would be able to go and take that, profile it, analyze it. So your role will be more and more relevant to your life cycle, right? See, a lot of things are getting automated, right? We'll be learning about a few of these things in the Gen AI session. The scripting is getting a little bit automated. Your analysis will get automated a lot. Preparing the reports will get automated a lot using this AI and Gen AI, right? So as a performance tester, your work is going to get shorter and shorter. So which means you have to have a broader knowledge. You have to be relevant to the entire life cycle. That is where performance engineering is going to help you to be more relevant. Though some of our work is going to be taken by GenAI in the future, it is very important for you to upskill you, transform you, or transform yourself to a performance engineer, so that there is no question about your applicability in a project. Okay, so the shift right in this diagram is the production. You as a performance engineer, you have to look into the production monitoring tools, analyze what is happening in production, whether the performance testing environment and production environment are same or not. There are things like synthetic monitoring, real user monitoring, where you need to create scripts, configure it. So there are a lot of things as a performance engineer, you will do it in the production as well. All this is something is going to be part of the performance engineering or performance engineer role across your life cycle. Okay, so what I'll do is next 15-20 minutes, I'll go over the various topics. Okay, feel free to put it in the chat if you have any questions. Okay, so as I mentioned, right, the first thing what I want you to come out of the mindset is it performance engineering? Is it something I can do? Because we are going to provide recommendation. We're talking about bottlenecks. We're going to talk about CPU. We are going to talk about heap, garbage, threads, objects, methods. So the first thing what I want to do is break that kind of a myth or break that kind of a mindset. For that, you should think like a developer, right? Not from an application development perspective, but more in terms of what a developer is going to do, right? If you can crack that, if you can get that kind of information, get that kind of knowledge, right? Then you will not feel that you are inferior. You will not feel that that less confidence approaching a developer, right? So what we'll do is initially we will have a session at a 1 or 2 session on the introduction to say Java, JDK, JVM architecture, what is class, what is object, what is your methods, what is package. We'll go and create few programs, we'll compile it, we'll create multiple classes, we'll try to call one class from another class file, we'll try to understand what is object, okay, and then we'll go and compile it, we'll go and run it, we'll try to see how one developer will make a connection to an HTTP service, how we'll make a connection to a database call. More, we're not going to go and learn the syntax. We're not going to go and learn object-oriented program. We're not going to go and learn data structure. No, nothing. We are not going to be a developer here. We're trying to understand what a developer will do. Our application project will look like in an Eclipse. Our typical application structure is going to be what are the packages, how the classes are going to be assembled in a package. We're just going to get that kind of a visualization. We're just going to try to get few things hands on, so that you don't need to worry about whether I'll be able to go and talk to developer, whether I'll be able to go and talk about the technical aspect. That's a pure intention of having this session. Think like a developer, okay? And then we will move on to the performance engineering topics. Okay, to start with, we will have a e-library application. Okay, so e-library application for me, it is running in my local in a Tomcat. Okay, so you will also be provided with the Tomcat software. I'll be providing you the WAR file, which you can deploy. How to deploy, how to install it, I will tell you probably tomorrow. And I also have a video instruction so that you can follow and do those same thing in your machine as well. All I need is you should have a laptop with Java. That's it, right? That's a minimal thing I want, your personal laptop and a Java to be available. Okay, so I'll provide you instruction on how to set up this e-library application. Okay, so this e-library application is what we will be using initially for our couple of engineering activity. Okay, so when it comes to any service or any application, you will have certain things: CPU, you will have thread, you will have memory, you will have heap, and you have threads, right? So even simple, if you go and buy a laptop, your configuration is going to be around your number of core, your processor, your RAM, and your hard disk, right? Hard disk space. That's how the typical configuration is going to be for a normal user, right? So which means any software we are going to install in that machine is going to have a boundary. It has to work within that CPU limit. It has to work within that RAM, correct? So whatever application you're going to deploy in that machine, it's going to consume CPU, it's going to consume memory, right? So your application should be optimized for CPU. Your application should be optimized for the memory. Any application, be it as a Python or .NET or a Java, that's a basic principle, because your hardware is going to be having that limit. You're not going to have an infinite. You might having a large RAM, huge processor, but anything is going to have a boundary, right? So your application has to be optimized for CPU, optimized for memory. Okay, so all our initial profiling sessions or initial engineering sessions is going to be around CPU, memory, heap, threads, all these four areas. Okay, so for e-library application, assuming that you are a performance engineer, you are getting involved during the development state, and for whenever a login is getting developed, whenever other transactions like view librarian, add librarian, whenever these functionalities are getting developed, your role is to go and make sure that these functionalities are all performing well from a response time perspective, CPU perspective, and the memory perspective. So we'll do these early performance engineering for response time and the memory, right? So we'll be using tools like JProfiler, JConsole for profiling and monitoring as we uh, go to one topic to another topic. Okay, so the first thing is going to be CPU profiling and response time analysis, and then from a response time perspective, it's not only server side, it's also client side is important. So for every functionality, you will be looking into both the server side and the client side, right? So we'll be like trying to understand what is client side performance, what are the various metrics we need to monitor, how are we going to use the developer tools to gather the information like time to first paint, time to contentful paint, your load time, and then we also will go and look into the from an engineering perspective the recommendations, right? How to reduce the number of requests, how to reduce the page size, and things like minification of your JavaScripts, minification of your style sheets, compressing your resources, right? All these things will be looking into it from a recommendation or optimization perspective of a client side performance. Okay, so CPU profiling for a response time, and then client side performance from a end user perspective. Both we will be the first initial session of engineering, right? And then as we move along, we'll go into the memory topics. Memory is going to be a very comprehensive, close to 5-6 sessions. We'll start with the memory profiling or memory leak analysis. We'll again use a JProfiler to look into the memory pattern. Again, we will use the same e-library application only to run for multiple iteration in Jmeter, and then understanding the pattern of memory, and then using JProfiler. If the pattern is bad, then we will go and do the memory leak analysis, right? Um, to to find out which method is having a problem, which object is leaking. All these things we will be doing as part of the leak analysis. And from a memory management perspective, we'll also try to understand some concepts, right? Like stack, heap, overall JVM memory structure, and role of metaspace. And then from a memory concept perspective, we will learn some theoretical steps, very important from an interview. And then we'll go into the heap dumps as well, right? Why to take heap dump, when to take heap dump, how to take heap dump, how to analyze the heap dump. So all these things are going to be part of your Java memory management. And then we'll also look into the part 2 of memory management is going to be more on the garbage collectors or garbage collection. So GC concepts, different collectors, and what happens inside GC, what are various components of GCs, GC tuning flags, when to apply these tuning flags. All these things we will learn from a Java memory management part 2. Okay, and again, for most of these things, since from a memory perspective, there is always going to be concepts. So some 30% will be theoretical, some 70% is going to be practical, using either e-library application or some standalone programs. Okay. From there, we will go to the threads. As I said, your entire performance is going to be based on your CPU, response time, your memory, and threads. Okay. So all these things you have to analyze it as a performance engineer during the testing, or before your load testing. You will be doing all this analysis either with a single user or under load. You will be analyzing all these aspects. Okay, so in thread analysis, we will be looking to the thread contentions, how to configure the threads, where to configure the threads, what are the various states of threads, and then how can a thread contention can come, uh, what are the various thread issues during a stress test, what kind of issues you can expect, and then your thread blocks. When to take the thread dump, how to differentiate a normal response time issue versus a thread lock issue, how to take thread dumps, when to take thread dumps, what are thumb rule for taking thread dumps, and then how to analyze a thread dump for identifying the problems. All these things as well we will learn from a thread analysis perspective. Okay, and one more important thing that you need to know is, from as a performance engineer, we spend a lot of time in scripting, we spend a lot of time in execution, but the original objective is to monitor, understand, observe what kind of issues are going to be there in your service, right? What is your report is going to be important as well. Your transaction response times, errors, all that you get from Jmeter or LoadRunner is important. Same way, for my components in my architecture, it can be 5 components, 6 components, it can be Java layer, it can be a Python layer, it can be a Kafka, it can be a database. All these components, whether it is doing good or bad, right? So this observability or monitoring each and every component is very, very important. So as a performance engineer, you should also have to prepare a monitoring strategy. Similar to your test strategy, you should have a monitoring strategy. So we'll try to learn what is the monitoring strategy, how you should look into the architecture, what are all things that you need to gather from a monitoring strategy perspective. How do you need to ensure that monitoring is available in every tool, in every component? Right? All these things we will learn. And then from a tool perspective, we will look into 2 tools from a monitoring. One is your open source monitoring with the Telegraph and Grafana for infra monitoring. And second is we will look into the AppDynamics as well. Right? How to configure the AppDynamics, how to set up your account in AppDynamics, and then how to connect your AppDynamics to the Java application that is running in your local machine, the e-library machine, right? And then what are the various aspects you have to look into any APM tool, not only AppDynamics, any APM tool like Dynatrace or New Relic, things are going to be common. Only the UI is different. But what, as a performance engineer, what we will look into the APM tool is going to be same. All your EP utilization, GC performance, your thread utilizations, all the business transactions, alerts, events, database calls, third-party calls, all these things are going to be common whether you're going to look into the Dynatrace or AppDynamics, right? So we'll try to learn what are all the various things that you have to look into it, how to diagnose the response time problem, how to look into the GC time, your major GCs, minor GCs, heap utilization, all these things we will learn from a AppDynamics perspective. Okay, and from a database perspective, we'll also go try to understand database architecture of Oracle, memory architecture, CPU architecture, very important performance related components like buffer cache, your parsing efficiency, buffer cache hit ratio, all are very important from a database performance angle. We are not a database performance engineer. We're not going to be a DBS, right? From an application perspective, you are application performance engineer. From that perspective, we'll try to learn the database performance. We'll also look into a couple of AWR reports, and we'll learn what are the things that you need to look into it in an AWR report. AWR report is going to be a very, very vast report, right? It's going to have a lot of information. You as an application performance engineer, you're not going to configure the memory of database. You're not going to configure your individual components of your Oracle database, right? That's a DBA work. You as application performance engineer, you might recommend heap configuration, you might recommend a thread configuration for your application, but not for the database. Database is always going to be owned by DBAs or the database performance engineers, not by us. From that angle, we will go and learn the database performance. Okay, and then we'll also, so now you would have covered all the, from a thread perspective, client side performance perspective, monitoring, thread dump, heap dump, GC, all these things you would have learned from the first uh, 15 or 16 sessions, right? And then we will move into the non-functional requirements and engineering strategy, how to write engineering strategy, or what is a non-functional requirement, how to, as a performance engineer, how you should go and collect requirements. As a tester, we might have just used whatever others would have given you, right? But as a performance engineer, we have to look into certain things and gather it properly. If the NFR is wrong, whatever you're going to do later is going to be make no sense at all, right? So requirement is very, very important. So we'll try to understand what things has to be analyzed, from where to get the requirements, what to get the requirements. We will look into it in detail. Okay, and then we'll go into the engineering strategy in an agile delivery model. What kind of testing you will do in sprint, what profiling you will do in sprint, and during the release end, what you will do, that as well we will learn from a strategy perspective. Okay, and then two things will be provided as a recorded video. From once you register it, you will get those videos. Okay, one is from the synthetic monitoring using Dynatrace, which will happen. Okay, in product, for a production monitoring, proactively monitor your production performance. Anything wrong, there has to be alerts sent to the support team. That's a synthetic monitoring. Okay, that recorded video will be available for you. You can look into it, and if you have doubts, we will clarify the doubts in the session. But the recorded video will be available well ahead. Similarly, for performance testing in DevOps as well. Okay, again, it's very, very important topic, performance testing in DevOps, because wherever you go in the interview, you will eventually will get, whether you're going to do it or not, you will get around get questions around whether you have experience in integrating Jmeter with Jenkins, whether you have executed performance testing in pipeline. So this particular topic is going to cover the myths around performance testing in DevOps, what best practices you have to follow from a practical experience. I would have shared those information, and how to integrate Jmeter with Jenkins, how to execute Jmeter from Jenkins, all these things as well I would explain to you. So that video also will be available to you, so that you can look into it, and if there are any questions, we can clarify it during any of the sessions at the end. Okay, and then we'll also have a cloud. Again, cloud is again a very jazzy word. It's been in software industry for the last 5-6 years. It's been very, very widely been talked about, right? So from a performance perspective, a lot of places there's a myth is, since application is in cloud, do we need to do testing? Do we need to do performance testing? Is it performance engineering relevant or not? Right? We try to understand why we need performance to be done even when the application is in cloud. What additional scenarios has to be executed? What is auto scaling? During auto scaling, what things can go wrong? What you have to monitor? How do you have to test it? And then we also go and learn about chaos testing or resiliency testing. What tools are available? What techniques you have to use it? Okay, we will try to go and learn all these things from a cloud and resiliency as well. Okay, and then we will have a couple of overview and some hands-on, some overview session on Python and .NET as well. Python is again very important, as I said earlier, because Python is going to be in every architecture nowadays. You will have Python and machine learning, right? So as a performance engineer, you should be able to, once you know one performance engineering from Java, you should be able to easily apply the concepts everywhere else, But since Python machine learning is there everywhere, I'll also explain you what tools are available from Python monitoring and the profiling as well, and also some of these common bottlenecks when it comes to machine learning implementation in Python. We'll also go and cover those as well, right? And we'll also try to understand how different it is going to be from Java, from a, JVM perspective, from a heap perspective, GC perspective. We will try to understand what's the difference, the way Java handles and Python handles. And we also go and learn some of these tools like your PS util, and then we also go and use some of these Python profilers, right? To look into the what are the various components in Python program where the time is spent, which function is taking more time, right? All these things as well we will learn from a Python perspective, right? And similarly for our .NET as well, um, similar to that, we'll try to understand again. Once we have learned Java, we'll try to correlate with Java and to understand how it is different, right? From a execution engine perspective, from a handling of heap GC, how it is going to be how it is going to be common, or how it is going to be different between Java and your .NET. Okay, and also we'll go and learn a couple of tools and profilers that is available for the .NET performance, right? Trace, your Azure Monitor, application insights. There are plugins available in the Visual Code Studio itself, that is from Microsoft. It will go and understand these things so that in an architecture you will have definitely all these components, right? See, still Java is going to be more relevant. It's going to be your core. Spring Boot is going to be a core application integration layer, but you will also find these Python or Node.js or your .NET specific components, right? You might have totally different components as well, like Kafka. You might have MongoDB. So there will be a lot of components in your architecture, right? Not that everything is going to be your responsibility, but if you end up in analyzing any components, again from a mindset perspective, after learning all these things in this course, right, you should be able to apply the concept, apply that mindset to any other component. Any component should be providing you certain tools, software to monitor the CPU consumption or memory consumption. There should be some inbuilt profiling tool that should be available to understand what is going within that particular component, right? Just that you should be able to go and explore it, look into the user manuals, look into their websites, look into the blogs, and then you should be able to go and experiment it, do a POC, right? Day one, week one, month one, you may not be able to do it for a new component, right? If it is a Java-based application, yes, after the completion of the course, you would be able to go and do it and so on. For Python and .NET, with the knowledge, whatever you're going to get, you can go and implement it or start doing the POC. But for other components, there can be anything, something that is totally new, right? It can be your programming language like Go, or it could be Node.js, it could be Ruby, whatever it is, right? You should not think that, okay, I don't know, right? Nobody, even I don't know. Even if I go to a project, if they have a application component where they are going to use the Node.js, I don't know, right? But definitely any programming language framework will have this native capability for sure, because any program is going to consume CPU, any program is going to consume memory, everything needs threads to get executed. So definitely they will provide some utilities, some kind of APIs, some kind of a tools to monitor it, so you can absolutely very sure about it. Just that you should have an open mind of exploring it and getting it done. Okay, so out of this, from the course perspective, you should be able to learn everything from a um, uh, uh, profiling to client-side analysis to EBDM, ThreadDump, GC, database, strategy, everything you learn it, and you can apply it to wherever you want, right? That is that is how we have tailored this course, so that from a performance tester, you should be able to take the next step of moving towards the performance engineer. Okay, finally, since your GenAI LLM is something talked about everywhere, anywhere, relevant or not, people doing some lot of experiments, lot of POCs, lot of use cases are involving these GenAI and LLMs, right? So definitely we wanted to give a overview on some of these as well. Okay, especially from a um, basic understanding, from a key terminologies like LLM, what is LLM, what is prompt, what is embedding, what is token, and then GenAI use cases in general, right? And when it comes to performance testing and engineering, how we can use this LLM or GenAI from a script generation, from NFR gathering, result analysis, report generation. The lot of use cases still evolving. No tool has come out with a proper GenAI implementation. LoadRunner has not done it. Jmeter has not done it. Your Blazemeter has not done it. No tool as such today have inbuilt GenAI capability, right? It's just for our community can make use of GenAI for these tools in a way, whatever way we want, right? So we'll try to understand what is the boundary of this script generation. Yes, it is possible, but to a certain limit. We'll try to understand from an API perspective how you can generate your API scripts. If you have a Swagger, if you know the requirement, yes, we can go and create a Jmeter script within a minute, within 5 minutes. You can go and get a Jmeter script generator for all the APIs, right? For UI based scripting, it's not going to be that straightforward. Maybe with using R, also not very straightforward because there is going to be a limit. GenAI is not going to accept huge files where you can look into it and it can generate scripts, right? It's not going to be that straightforward. So there's always going to be a limit to which you can use it for a script generation. So we'll learn about that. NFR gathering, right? So for an e-commerce application, for an order management system, for a banking application, right? Uh, your GenAI as a very wide knowledge, it is trained with a very wide knowledge, right? So it will know for an order management system or for an e-commerce retail application, right? What is a typical NFRs, right? What scenarios has to be tested for performance? Those kind of information you can use a LLM to help you out to creating a strategy, to create your not exactly your workload, but more from a non-functional requirement, your critical transactions, frequently transactions, right? So a lot of information, lot of knowledge you can pull from LLM for your NFR gathering. Okay, and then result analysis. You might have data from Jmeter, you might have data from LoadRunner, you might have data from Dynatrace. So you can collate this data and then ask GenAI to analyze and provide you the observations, providing your summarized report. It can again look into your raw files and it can provide you a very good summary report of saying what went wrong, what is good. Right? Again, you have to be an SME in these things in performance. Only then you'll be able to write a proper context, provide proper data. GenAI is going to be as good as your input. If your input is bad, if input is wrong, and your questions to the prompt is nothing but your instructions. If your instruction is wrong, instruction is incorrect, the output is going to be totally inaccurate. We'll try to understand how these things are done in a typical project. Okay, and also we'll go and look into some of these LLMs that is available with Google or Microsoft with AWS. Right. So